Okay, guys, so today we're talking about rational exponents. So 1 through 5 should have been fairly simple. The square root of 4 is what?
2.
Square root of 36?
6.
100?
10.
49?
7.
16?
4.
Okay, so y'all should have been fine with that. That's something y'all should have memorized. Now, when y'all plugged in the next set of problems, what did y'all get? The same answers. 2, 6, 10, 7, 4. So the square root of 4 is the same thing as 4 to the 1/2 power. So the square root of a is going to be the same thing as a to the 1/2 power. Okay? So we can write, instead of doing the square roots or cubed roots or whatever, we can just write it to a fraction power. So the same thing happens here. The cubed root of a is the same thing as a to the 1/3. Fourth root of a is the same thing as a to the 1/4. So that means the 14th root of a would be the same thing as a to the 1/14th power. Okay? So the bottom number of that fraction is going to be the root. Now, if there is an exponent in the radicand, all right, you can use this formula. The nth root of a to the m power is equal to a to the m over n. And you guys were going to apply that down here. So I know that's a little confusing when you first look at it, but as we apply it, it makes more sense. So that means the number outside of the radical goes where? The denominator. And the exponent inside goes to the top, okay? So we can rewrite this as 40 to the what over what?
8 over 3.
8 over 3. Okay, inside goes on top, outside goes on bottom. So right here, the cubed root of a to the 7th is a to the 7 over 3. The 5th root of z to the 11th is the same thing as z to the 11 over 5. And number 4, y'all checking what you guys got? 1,000 to the 2/3. And then we get a fun one with number 5, okay? So we got lots of stuff inside of our parentheses. So just like we've been doing, we do one at a time. So a to the 4 over 6. B to the 8 over 6. And C to the 12th over 6. And can we simplify these exponents? We could, okay? We're not going to do that right now, but we could.
Can you test to want us to simplify?
Yes.
Could you solve 1 and 4 too?
Say that again.
Could you solve 1 and 4?
You could calculate 1 and 4, absolutely. But we just wanted to rewrite using exponents. Okay, so for our practice, 81 to the 1/2 power is the same thing as the square root of 81, which is 9. The square root of 38 is the same thing as 38 to the 1/2 power. Okay, 12m to the 1/2. Now notice that 12 does not have the exponent, so that 12 stays the same. And m to the 1/2 is the same thing as the square root of m. Here, the 32 is inside the square root with the w, so they're both being raised to the 1/2 power, so we have to use parentheses. Here, 7w is all to the 1/2 power. So 1/2 power means we're going to do a what root? A square root. So basic one. And both of these things are inside the parentheses, so both of these things go inside the radical. So 7w, square root of 7w. Here the 2 is outside, so the 2 is going to stay outside. X is being taken the square root of, so that's the same thing as x to the 1/2. Okay, did y'all get these? Okay, awesome. On the back it's a little bit trickier. So on the back, we had to simplify these. So what it showed us was 256. We broke it down. 256 is the same thing as 4 times 4 times 4 times 4. So the 4th root of 256, well, we have 1, 2, 3, 4s inside. So 1 4 comes out. So since it's the 4th root, for every 4, 1 comes out. Okay? The 6th root, we have to have 6 of the same thing. So this number can be 5 times 5 times 5 times 5 times 5 times 5. That's 6 5s in there. Since it's the 6th root, for every 6 5s, 1 5 comes out. So if I have the square root, I didn't need that 2, of 4. 4 is the same thing as 2 times 2, right? So the square root of 2 times 2, well, there's 2 2's. If it's a square root for every 2 2's, 1 2 comes out. Because the square root of 4 is 2.
So every single one.
The cubed root of 8, that's the same thing as the cubed root of 2 times 2 times 2. Well, there's a set of 3 2's in here, so 1 2 comes out. You have to have 3 buddies in a cubed root for it to come out. You have to have 6 buddies in a 6th root for 1 to come out.
So
Okay?
you had to have 3 buddies. Okay.
Huh? Because there has to be a set of 6 for 1 to come out. If you don't have a set of 6, you can't take the 6th root.
I see what you're saying.
Okay?
Why didn't
Well-
you just count like you just take
Count normally.
Yeah. Why can't